Hi everybody, this is Tor Storley and I am back with another video. So in this 7th video in this series, what I want to look at is two things. I want to look at how can I load a large file into DuckDB, and if I do need to distribute the data from that large file, how should I go about doing that so I get the most efficient way in a file system. I want to show you how to load a large file, and I also want to show you how you can partition a file into smaller subsets so the efficiency of the queries against the file will be much better. So let's get started. So I'm just going to open up an instance of DuckDB CLI. So I have this bat file. Watch my previous videos if you want to know how that happened. So I'm going to open it like this, and because my monitors are set up in a certain way, I have to drag it over. So here is the actual CLI. If you do recall, you can do like show databases. As you can see, it's in memory. So it's just internal in memory right now. There's no persistent database. So what I want to do is I want to start a new database. And I decided in this video, I need to use a large file. So where am I going to get a large file from? Well, I so happen to go on this GitHub repository, as you can see up here. It's corgis-edu.github.io/corgis/csv/airlines. And this is a CSV file. So it's pretty large. It's around 11 gigabytes, so it's plenty of records in there. In addition to a lot of rows, it has a lot of columns as well, as you can see down here. So what we're going to do is we're going to try to load this data into DuckDB, and then from there we're going to see how we can partition it out to other format in order to make the efficient capabilities of DuckDB's query engine work faster. So what I have here, since I'm in memory right now, so if you want to download this file, by the way, just go here and click this and you will download that file. All right, let's bring up my CLI again. I'm going to maximize the window. And if you recall from previous video, you can use this .open command, set a reference to where you want your database to go, and then give it a name, like you can see here, airlines.db. That will create a new blank persistent database called airlines. All right, so it's done. In order to see all these columns and so forth, or you might have to make some justification to the mode of the CLI. Now, what I'm going to do here is I'm just going to run this query first. I have this file stored in a certain folder, and that folder looks like this. So it's called airline.csv. And as you can see from this one, if you look at the properties here, you can see it's 11.2 gigabytes. You can see it in the margin over here. So it's quite large. So I want to create this database in this position. Now notice I already have one here called airlines.db. So if it exists, it will simply open it. If it doesn't exist, it will create it. And that's what this .open statement does. So let's run that, and which I already did. So it's open now. So again, if I do this show database again, notice now it's pointing to this airlines database. Okay, so now we got a airlines database in DuckDB. One thing you can do in DuckDB for CSV files, it has very sophisticated CSV file loading because it's such a common file format. They have spent a lot of time trying to make this as simple as possible for you. Now, CSV by definition is very slow. So you don't want to use large CSV files. You want to convert them, and that will take a little while. But once you have it converted, it will be much more efficient. So let me show you what you can do with these CSV files. And I briefly touched on this in the previous video. You can use what's called a sniffer. So notice it says sniff_CSV. So here I can select from sniff CSV, which is like a metadata about this CSV file. It will go and inspect, and you can also set number of rows, and you can look at my previous video how you did that. But here I'm saying, because in this file there are some records that gives you a UTF error. And I don't really care about this data. This is just for demo. So I'm going to try to load this data, and if it covers a error somewhere in some of the rows, I'm simply going to use this flag and say ignore errors is true. Therefore, it should just bypass those rows. So notice I'm using sniff CSV. So what does that do? Well, let's try it. Notice it gives you a description over what it thinks this CSV file contains. So notice the delimiter, it thinks is a comma. There's quotes in here. The new line character is /n. And here is the struct, meaning the names of that particular file, if you will. So one thing I could potentially do here, and let me set this up and then I'll come back right away. So let's try this. I'm going to change the mode to align mode. And then I'm simply going to query out one of these columns because it has a lot of fields, as you can see here. So let me try to query out this columns field and see if that gives me something. Now, if this causes an issue, we might have to do a different mode again. So let's try it and see what it does. So let's paste that in here. And here you can see, here it gives you all the column names. So as you can see, there's one column. Here is that of type varchar. Here is another column of type varchar. So you can see here, it went in and identified all the columns in that CSV file and returns the type of it in addition to the name. So that's one way you can use this. Actually, I'm going to put it back to box. So I'm going to say mode, box, and then let me run this column now. So notice I'm still reading from that CSV file, but now I want to describe it. So as you can see here it gives you all the column names and the data types. So this is a cleaner format than you see up here. It's just a different way of describing it. So here is all the columns. As you can see, there are a few columns in this. One of those that are interesting for me is year and potentially month, because that gives like a time. There's also, if you want to split up by type, for example, by carrier, you can do that. Oh, here it is, unique carrier, as you can see. Okay, good enough. So that describes it. Now what I want to do is I want to create a table, but I'm not going to run it because it takes a while to run. Okay, so the first thing I want to do is I want to see the size of this database now. So I'm going to say pragma database size. And you can see the database size is currently 3.7 gigabytes. Now keep in mind, those files, the CSV files, was 11.2 gigabytes. So as you can see, DuckDB has done a good job of compressing all the data in here. And it's also storing all the data into columnar formats. So it creates block sizes and how many blocks it's going to be putting in here. So it does a very good job of compressing and make this a lot more efficient. That's how you can use this pragma database size to get an overview of the size of your database. The next thing I want to do is I just want to summarize my table here. Now the problem with the summarize means that it's probably going to be wrapping around because it's a box format. So I'm running it and it's going to run over all this data. And as you can see, it takes a little while. And I'll show you why in a second here. But let us finish. So it's trying to summarize all the data in the columns in this table and show the different statistics on it. So it's going to run a lot of stuff over this 3.7 gigabyte database. And here you can see it came back with it. So here you can actually see the size of this. Notice it's 120 million rows with all these columns here. So it's quite large, but it's compressed into 3.7 gigabytes from 11.2 gigabytes. So here we'll give you some statistics over each column. It's like min, max, and because these are varchar, we'll give you -1 here. But you can look at this yourself, and there's also an indication how many unique values there are, etc. It can say it took about 25 seconds to run 120 million rows in all these columns. And I haven't counted these columns, but anyways, it's quite a bit of data. Okay, that's how you can get some statistics by using the summarize. Now, the next thing I want to do is to show you the methods that I used to actually run this. I want to get a clean slate here so we can look at a difference. I'm going to close this session, opening it up again. And of course, I have to use my open statement again so I can get the database open. So I'm doing that here. Now, what I wanted to show you is, I'm not going to run this, but I'm going to show you the context of this. So let me open this for you and show this in a notepad window. So as you can see on my screen here, there is, let me see if I can make it a little larger. So as you can see, you can actually query data out of the airline table here. And here I'm using the copy command, select everything from airline, which is the table in that database. And I want to move it into this folder, into the airline folder. And I'm creating a new one here called partitioned. And the format I want to use is parquet. And I want to partition it by year. So that means all those 120 million rows will be partitioned into its own folder with its own parquet file that will be named by this particular code that writes this out by year. So we'll create a new folder for every year, and then depending on what you do next will determine how many files in that folder you will have. Here I'm also using overwrite or ignore is true, meaning if it exists, just overwrite it. You need to experiment a little bit because of the size. There is something in, if you have ever worked with Spark or PySpark in particular, that when you run on these big jobs in Spark, you might have to partition or you have to break the job tasks in to a certain amount. And sometimes when you're writing these files or what have you, you want to set the limit of the size for these files. If you have the too many files, too small, it takes up more compute. If you have too large files, it will take up more compute. So you got to strike a balance between how many cores you can run this over and how big these files are for reading. So as you can see in the second one here, when I ran this first one here, you can see it took about 9 minutes and 13 seconds to run. It's a little hard to read because I have this theme in here, but it says 9 minutes and 30 seconds. Now, obviously, I used that timer, but I converted it into minutes and seconds. Now, this might be my preferred version of it. Notice what I do different. It's the same thing, but I'm creating a second partition here, and I'm just setting it to 128 megabytes. Now, the 128 megabytes is really like a recommendation size they use in Spark, but it doesn't really pick it up when you use this 128. So when I tried the first time to use 128 megabyte instead of the 100_1000 here, it didn't like it. So I'm setting the row group size to 100,000 here. And again, I use the overwrite ignore. But in the documentation, you can also see an example of where they use a compression. Now this took longer because it compresses it. But if you look at it, it took 16 minutes and 54 seconds. So just ignore this particular line here. So what does that look like? Well, let's go and take a look at it so you can see what it looks like. So after I run those two queries, as you can see here, it produces this. And this partition folder was the first one without the compression, etc. So if you look at it, notice it created a folder for every year. And the years for these airlines was from 1987 to 2008. So if you look at inside one of these, notice it gave it a name data_0. So if there was more parquet files, if you broke it up further, it could say maybe data_1, data_2, etc. So it does this for every year. Now, that's not the end of it though, because technically speaking, you could have, for example, you could say partition by year and month like this. But the problem with that is you got to be careful because suddenly you're getting more folders, 12 under each year, and then you'll get very small files, so they might not be very efficient. Plus, it will probably take a lot longer to run. So there is a balance here you have to figure out how to do this. Anyways, I just wanted to show you these statements. Now we can look at the files that it produced. So as you can see in here, this is why I used the first one. And as you can see here, when I highlight this one here, you can see this one is 307 megabytes, as you can see over on the right-hand side here. And I'll be zooming this in for you later. So that's in megabytes. This is just bytes, so kilobytes. So here, that's 317. And for example, if you do another one, maybe 1999, and click, you can see that's 231 megabytes. So I thought that was too much and potentially will work, but I said I'll try the other one, the compressed version with the limit of 100,000 rows. So what that one looks like is this. So for the 2008, you can see when I select that guy, it's 186 megabytes. It's actually 187, closer to it. And if I go back to that other one, like 1999, I believe it was, you can see this one is now 135 megabytes. So it's more compressed now, and it's smaller size by using this type of partition. And again, just so you remember, I use compression here for that 128 megabyte folder, and I use the row size here. So that's how you can partition the files into smaller, and now it makes it a lot more efficient to query it. So next we'll look at some more related stuff that goes into this partition. Okay, so you looked at the file system of how you can read the size of all these partitions. I came up with a way in DuckDB how you can also do something similar, but in a maybe a little more easy to read way. So here I got this query that I'm using a CTE again. And from here you can see I'm selecting a file name, compression, and then I use, because I want to see some, I want to see it in megabytes here, so I'm using conversions here, and I'm formatting it so I can get like a comma separated thing. And here you can see I'm querying the compressed in megabytes because it was in kilobytes, and the uncompressed in megabytes. Well, keep in mind, depends which folder you're going against here, because if you go against this 128 megabytes, remember that's compressed. The other one is not compressed. Well, it might be compressed, but it's not compressed with the compression that we did for this one. So you could test that other one too by referring to that other partition like this. Well, let's run them too and see what happens here. So I'm doing from this CTE, I'm gonna query out these fields. So let's try that and see what happens. And it's running. And it took about 1.48 seconds. And here is the list over all the files. Now, they came out a little short, so I want to run this one more time. And when you look now, you can see here is the file names inside each one of these year folders. So you have data_0 parquet format. And here is that compression we used. And here you can see the size of the compressed megabytes. Let me try one more time here, and I'm going to try to run it over that other folder just for fun to see what the difference is. So let me do that and set it up. It's kind of hard to get it copied here because it doesn't necessarily take it, but okay, let me try it again. So now I'm going against this partitioned folder, not the partition MB 128 folder. So let's see what that one does. Okay. So here you can see this is the compression on that compressed one. This one used something called Snappy. I don't know what that is. And the first file, as you can see, was 28 here in compressed form. The second was 100. In the other one here, you can see the first one was 48 and 175. Now, keep in mind, that doesn't tell you much because the file size of this one was bigger to start off with. For example, the file size for the 2008 file was 785 megabytes. Well, I'll take that back. That's 785 as well. It looks like it is actually working. So for whatever reason, it compressed this guy down much better than it did down here because this is 317. And again, we kind of forced this. So I don't know how to read this. But anyways, this is compressed and it's much smaller file size. So that's probably a good thing and it'll probably be fast still. If you have problems with the speed, because the first time I ran this, 33 seconds. One thing you can do to optimize the speed, if you haven't set this up on your database already, you can use this technique. You can set pragma and number of threads. So here it's going to run over 4 threads instead of 1 thread. And here you can also set up memory limit of how many you have. Now, when I first opened this, I have quite a bit. So this is not a problem for me. It runs pretty quick. But again, you can also force it to run much faster. So when I did this threads to 4 and my my memory limit to 4 gigabytes, it ran in like 3 seconds or less than that, basically. I'm sorry, in 1.3 seconds. And when I ran it without, it took 34 seconds. So it was much, much slower. Another thing we can do, we can also run and see if what our settings are, for example. And one way you can do this is simply run this select name from settings, for example. And as you can see here, it gives you a bunch of settings. However, it doesn't show all the rows. And I want to see all the rows. So remember from the previous videos, you can set this .max row equal to whatever. I can set it to 100 here because there's only 81 rows. So let me run that. And let me try to run that command one more time. And as you can see now, we're getting all of them here. It doesn't cut it off. So the one thing we were interested in was this threads and that memory limit. So here you can see those two. So in other words, if I want to find out what those are, how can I do that? Well, this is a function. So you can still run it as a query. It's a table function. So you say in select star from this table, which is the function, where the name is in threads and memory limits. And when you run that, you're getting back the threads and the memory limit, and it will tell you here's 4 threads and 3.7, close to 4 gigabytes. So that's one way you can get that stuff. If I want to watch some of the data that I have in that airline table, I can simply use this code from airline limit to. And when I run that, you can see it shows this. But notice it cuts off these columns here. So if you want to see them, you have to set the mode a little different. You can use different formats like HTML, JSON, you can use line, or you can use CSV as well. That might be the one you want to use. So if I did this, mode, CSV, and then I run my query again, here you'll be able to see at least the data here, but it's not the best output. Okay, so another thing I might want to look for is I want to look for the unique carriers. So when I run that guy, you can see it comes back with all the unique carriers here. So if I want to find out, for example, in 1 year's data, what is the United Airlines, how many records does United Airlines have? Well, I can do that from my table. If I do it directly from my DuckDB table, and I go like this, again, I have a problem with the copying. So copy, paste. So as you can see, there was 7 million rows of United Airlines was in there in 2008. I can also run that same thing against my parquet file for whatever. Remember, it's a partition now. So what I can do is, and I'm just going to use that first partition in this case. So let me paste that. So notice what it says. Select count star from read parquet. And here I'm pointing to that partition folder, which, if you remember, is this one. And I'm not pointing into any specific file here because I'm using the star. Notice, whatever folder is the star, whatever file name is the star. So it will just go through and it will look for it here. But it can push down these predicates into the parquet file and locate where this will exist and come back with a result much faster because now it's in the parquet format. So I want to select all the counts from where year is 2008. Okay, so it comes back right away, not a problem, because it has count figure. So that might not be the most interesting query. Now, if I want a little more interesting query, I might want to add something to the where clause. Here I'm saying I want to count from whatever under whatever subfolder under partition where whatever file name parquet, the unique carrier is equal to UA, United Airlines, and the year is 2008. So now I'm looking specifically inside the file, and I need to locate UA. It comes back right away, as you can see, and this is what it found. So it took 0.149 of a second or so, very fast. If you liked this video, give me a like and consider subscribing to my channel. That'd be great. Have a great day, great night, wherever you happen to be in the world. We'll talk soon. Bye-bye.